not force a term on a rock. Let the rock tell you what it is. So you're just making observations. When you look at what? What do you need? I'm in the middle of something. 12:30. So when you're looking at number 2, what it shows you is a fine-grained rock that is light colored, right? It's pinkish. So you're going to call it, you're going to say that it's a low percentage of dark minerals, or just call it light colored. You're going to say that it's aphanitic, or you don't even have to use that term. You can just say it's fine grained. Etc. Do you see what I'm saying? Like, don't.
Yeah, I do.
Okay. So you don't try, when you can't see any minerals, don't try to like you're trying really hard to identify it. And that was a good guess, right? To compare it to case feldspar, but you're forcing it. And it's a mistake, because even though the colors are similar, the color in the rhyolite could be due to something completely different than its mineral composition. Like I said, the oxidation state of iron can give a rock, a volcanic rock, a certain color. Like this andesite is kind of greenish, right? And
Yeah.
that light colored rock, number AO2, is kind of pinkish. Both of those colors could be literally the oxidation state of iron. It either gives you a green color or a red color, depending on if it's iron +2 or iron +3. So it's a funny, that's why I say, like, color's not reliable. So just let the rocks tell you.
Got to focus more on like on the actual like texture on the rock than in the actual color of it.
And yeah, try, before you go to the visual bank and compare, just make some notes about what you see. Right?
Okay.
Just write down what you see. And if there's a column for a question like list any identifiable minerals, and you're looking at AO2, there aren't any. So just say NA, none, or exit out. You know what I'm saying? Don't
Yeah,
fill.
yeah.
Okay. But number 2, or sorry, 3, with the white minerals and the black minerals, you could make some guesses there.
Mm-hmm. Oh yeah. So I would.
Yeah, this is very helpful, in fact, to look at the
Yeah.
page. So in a rock, the feldspars look white and opaque. The quartz looks kind of grayish and translucent and glassy. The dark minerals, they only point out biotite, I think, but the left-hand side one next to it has hornblende and biotite in it.
Yeah.
So if you can see the dark minerals, if you see a nice flat glassy face, like perfectly flat, then you're looking at a mica, you're looking at a biotite. If what you see instead is like an elongate, kind of narrow but long crystal doesn't have a flat face on it, then you're going to guess hornblende or an amphibole of some kind.
Right.
Right. And then their example of augite right there, that's a pyroxene. It's kind of greenish black. So that's how you differentiate between hornblende and augite, between a pyroxene and an amphibole. The hornblende is the amphibole, the augite is the pyroxene. But you did a great job on number 1, and you think it's this mineral on the right, don't you?
Sorry, can you say that again?
So
You kind of broke.
rock number one, you said was 100% green.
Yes.
So did you identify the mineral?
Yeah. It
Did.
was Olivian.
Olivine,
Olivine.
olivine. Yeah,
Olivine.
great. That's exactly right.
And then it was I said it was a crystalline.
Yep. Yep. It's phaneritic, it's plutonic, and it's a dunite. You got that one 100% right.
Okay.
So you're on the right track. You just got off track with that the the second one.
Yeah. Okay. So like with like number two, would I for the minerals can I could put like
So you can't see any. You really shouldn't guess.
oh okay, because
Even
I
though
thought
it
that like
looks pink like the K feldspar. Only if you can see visible crystals should you try to guess.
oh okay. So I meant not number two. I meant like number three. I
Number
was
three,
gonna say I was gonna say would it be like how do you pronounce this? Sorry.
plagioclase.
Plagioclase feldspar with
Yeah,
biotite
yeah, biotite. Most
biotite. Sorry.
most mineral or rock names end with ite.
Right. Okay.
So biotite, andesite,
Bio.
rhyolite. Yeah. Um, let's go look at the picture of number AO3 together. So if we could zoom in and let's see if we can see actual mica crystals or if they look more prismatic like hornblends. Okay, zoom in on the black crystals.
That's as far as it can go.
Okay. There could be some biotite in there, but I think most of what we're looking at is not biotite because I don't see any flat, glassy surfaces. Do you?
Oh, okay. Yeah. No, I don't.
Yeah, so I think we're looking at hornblends.
Oh, okay. Now I totally get this. Yeah.
Yeah. Does that make more
Horn.
sense?
Yes, definitely.
Okay. There might even be a
Hmm.
little bit of quartz in here because look at like right in the middle.
Yeah,
Yeah,
right
right
here,
where
the
you're
gray.
right there. Yeah, it looks kind of grayish and translucent. Yeah, there's some quartz in there too.
So it would be plagioclase, like feldspar,
Uh-huh.
quartz, and hornblende all
Yep.
together in this one rock.
Yes.
Do you want us to say like the percentage of all of them or
That's not necessary.
okay.
I mean, if you want to, go for it, but it's not required. I make my students in mineralogy and petrology do that. They have to estimate the percentages of all the minerals in their rocks, and then they use those triangular diagrams and try to plot it on there to get the true name. Here in this class, we're a little looser than that, so we're gonna give like broader estimates of the rock type, the rock name.
Oh, okay. So yeah, now I see what you're saying between the difference between hornblende and biotite.
Yeah.
Because like biotite is like more glassy, while hornblende is like more like a rock surface.
Yeah, you've got biotite in your mineral kit, right? And you can see it's got a glassy flat surface on it.
Yeah, I do.
Yeah, so that's what you're looking for when you zoom in on those dark minerals is any indication. They might be very small, but any indication that there are these flat glassy surfaces.
I actually have to admit, this actually looks like my kitchen counter.
Oh yeah, that's pretty.
Mhm.
You even have the pink feldspars in it?
I think yeah.
Oh, fun. Now you can identify your kitchen counters. At least they were probably right when they called it granite. The people who supply countertops like that, rock countertops, it seems that there are very few They either call it granite or marble, and that's about it. And so a whole lot of things get called granite
Oh, wow.
that aren't granite. But that's just, as a geologist, I laugh at that a little bit.
Right. Yeah.
Do you want to look at another one together
Um,
before we're done?
I I actually have another quick question. It's like this classification table
Yeah.
because I know that we need to use it as well, but I'm still like a little confused like on how to like use it because I know like we use it like once we discover like all the properties of a
Right.
rock.
Right.
So
So you're trying to match the characteristics to the rock that you've got in front of you, right? So
mhm.
you're trying to be true to the composition, whether it's light, dark, or intermediate, and to the texture, whether it's phaneritic, aphanitic, porphyritic, glassy, fragmental, whatever texture you see. So this helps you to make sure that you're not, that you give a rock a plutonic rock name when you see a phaneritic texture, when you see all the crystals visible. There are large visible crystals in the rock. It has to be a plutonic rock name. So that's where that top row, phaneritic, comes in. So if they're all coarse crystals, then you need to give it one of those names. But if you've got fine grain rock that's either aphanitic or porphyritic, like porphyritic has a fine grain matrix with big crystals in it, and aphanitic is just all fine grained. So then you go down that row, and if it's aphanitic, like number 2, then you would then use the color index or any indication of its composition to name the rock. So number 2 is aphanitic and it's light colored.
Right. Okay.
So what would you name it?
Aphanitic. Um,
Yeah,
would it be
yes, yes. You keep going
rhyolite? Yeah.
back there. Rhyolite.
Yeah, rhyolite. That's what I thought.
Yes, I would agree. That looks like a rhyolite to me.
Okay.
Great. So so any other textures that you see that are aphanitic like that, I didn't give you any fine grained tufts because I knew that that would be too difficult to identify this way, right? I only gave you volcanic rocks, like just not fragmental rocks, not pyroclastic rocks, but the product of a flow. So they would be aphanitic or porphyritic if they're volcanic. If they're pyroclastic, which admittedly it's also a volcanic process, but it's explosive. If it's fragmental like that, then you need to go look for a different name, like a tuff of some kind.
Okay.
Because I saw you were headed towards tuff, which would have been a good guess, actually, because a fine-grained felsic tuff with no bigger fragments in it would look very similar to a rhyolite. So you weren't off in that sense, and I probably would have given you credit. Where I would have taken credit away is that you called that texture fragmental because
Oh, okay.
you didn't
Yeah.
see any fragments,
Okay. Okay.
right?
Yeah.
Okay, I think you're getting
Yeah.
it.
So, yeah, little by little. I'm getting it a little bit.
Okay.
Um, s- is there a chance to that we would get like any of these? Because I only saw
You
like
have
the
at least one of each. Yeah,
one of each of these two.
at least,
Of,
yeah.
Okay.
One of glassy, one of fragmental, one of bubbly, one of the others. Yeah. At least,
Okay.
I'm saying. There may be more than one.
But what else was I going to
Do you want to look
Oh
at any
yeah, so
other?
like number 4, you can't identify like any minerals, huh?
Let's zoom in before we decide that. Yeah, going as far as you can. Okay, what do we see, if anything?
Actually.
Not a lot. Wait, is 4 on your list? I don't think 4 is on your list.
Oh, I don't think so. Maybe not. Maybe, oh no. Oh no, it's not.
Yeah, I
My
took
bad.
that one away because I thought it would be too tricky.
Here
Let's
we
go
go.
down
5.
to 5. Yeah. Okay. So if you just go to your identification table, you don't have to switch it over now, whatever's in front of you. But what color index would you call this? Or what percentage of dark minerals? Like how would you identify that?
It would be a mafic.
I would call it but dark, right? Mafic is
Oh
identifying
yeah,
the
dark.
composition. Yeah. So you'll probably write mafic down in the composition, but to start, it's a dark rock.
Hmm.
What texture does it have? Does it have any identifiable minerals in it?
No, it doesn't.
No. What texture does it have?
Crystalline.
Crystalline.
It,
Okay. But tell me about the size of the grains.
um.
Are they small? Are they large? Can
Oh
you
no, they're large actually.
can you see any individual minerals there?
Mm, no, I can't actually.
No, you can't. So no, they're small. They're very small. So you could only see the crystals if you looked under a microscope. So we'll call this aphanitic or fine grained. Like I said, you don't have to use aphanitic. That's what the geologist would say. But if you just said fine grained, that's fine.
Okay.
No identifiable minerals. It's fine grained or aphanitic. And it's mafic because it's dark. So you have enough information to name this rock already, but we haven't filled out all the cells in your table.
So if it's sorry.
Okay, so what do we?
So we already said that it's a fine grained, it's a dark mafic, and that it's crystalline
Uh-huh.
structure
Yep,
with no minerals.
that's right. Is it volcanic, plutonic, or pyroclastic? Remember, volcanic will always have a fine grain matrix. Plutonic will
Oh,
have
then
all large crystals, and pyroclastic will be fragmental.
volcanic, right?
Yep, volcanic.
Okay. So then,
What are you going to name it?
sorry. Um. So if it's aphonetic with a mafic, is it basalt?
Yep.
All right.
See how easy that was?
Yep. I think I'm starting to get the hang of it more.
Good.
And the metamorphic rocks that is just the um well um metamorphic rocks that is from the our mineral kits, right?
These are
I mean,
the,
like
so there are
we still have
five.
to,
Go ahead.
sorry, we still have to do it virtually, of course.
You're going to do the 5 virtual metamorphic rocks, and then you're going to match them to the rocks in your kit.
Okay.
But you're also going to match them to a protolith. So you're going to look at them, look at their composition, like what do they have in them, and think about what kind of rock did it have to be originally to get you that kind of metamorphic rock. And there are unknown protoliths in there, but they go through pretty good, there's a good explanation, visual explanation of all that. You know, so if you find a marble, let's say, marbles will fizz because they're made of calcite. And so if you have a rock that actually passes the fizz test, then it had to have a protolith that was mostly calcite. That's a limestone. So that's how you're going to do that.
Okay.
The first thing that every time, when you start your metamorphic rocks, though, the first thing you're going to do is decide whether you see a foliation, so any planar texture at all, or not. That's the first distinction. Because if it has a foliation, then it has to get one of 4 names: slate, phyllite, schist, or gneiss. And then I went through in the lecture how you distinguish those. But if it doesn't have that texture, then you're giving it maybe one of the special names that we talked about, and marble is one of those.
Um, okay, yeah. I was just trying to see like if I have like any more
Sure.
questions.
Go ahead and scroll through and see if you have more questions. It's fine. I'm looking at something else right now while you're thinking.
Mm, yeah, just one more question actually.
Okay.
So how did you say that we would notice the
Protolith.
yeah, portalith number? Sorry.
So follow the instruct. There's a link to go to. So go find the link to the protoliths in the instructions. It should be towards the end. Okay, unknown page. Identify. Nope. Step 6. No. Wait. You're going too far back, I think. It must be Metamorphic rock kits. Maybe it's step 8. What does that say?
Okay.
Oh, that's metamorphic minerals. Where does it talk about? Wait, I'll search my own copy and see. Um, huh. Oh, wait, I think you're not. Oh, there you are, right there. Step 3, protolith page. Oh, I didn't give you a link. Shoot. Okay, use the same web page so as the other one. If you go back to that website we've been at, I will tell you how to change the URL to get to the protolith. You just add protolith to the end. So go there. Yeah, click on that. And now instead of classification, change that to protolith with an F, actually protoliths. And actually change the IgG at the beginning. Make that protoliths. There we go. And then change IgG to MEG.
MEG.
EG.
Oh, sorry. Yeah, EG.
There you go. That ought to take you there.
Also, the protolith is like the parent rock of like the rock that we identify, basically.
Correct. Right.
So the rock that is older. Okay.
Before it was metamorphosed, what was it?
Okay. Yeah, no problem. So if we say that if it was slate, then it would be like phyllite, right?
No, those are all metamorphic names. That's a progression of metamorphism that you're looking at right there. That's not the parent. The parent, if you scroll down a little bit, is shale or siltstone.
Okay, my
Blue
bad.
ones are the protoliths. The pink ones are the metamorphic rocks.
Okay, so my bad. So if
you had a slate, you would have a shale or siltstone protolith.
and then it goes, and that's the same for like schist as well, right?
Exactly.
Shale.
Slate, phyllite, schist, gneiss are all derivatives potentially of shales.
Okay, yeah. And then limestone is like the parent, is like the protolith of marble, right?
Exactly.
Okay, yeah, that makes
The one
total,
thing
yeah.
that this table is missing that I wish it had was oftentimes you see like a typical gneiss that has, stop. Sorry, there was an alarm going off. Excuse me. Kate, you have 5 minutes to get on Zoom. You have 5 minutes to get on Zoom. Here's the link. I'm going to forward it to your email, okay? I'm sending it to your school email. Okay. Okay, so back to gneisses. They often have a typical gneiss is light white colored bands, black bands, like light and dark layers. That's the compositional layering that makes it a gneiss, right? It's supposed to be a high grade metamorphic rock. And sometimes it's more logical to say that those have a granitic protolith actually than a shale protolith. So if it looks like just like a granite except in metamorphic form, it's okay to say, I think it probably was a granite.
Oh, okay.
That makes more logical sense to me than trying to look at that compositional banding and say, oh, that looks like a shale. It doesn't really. But slates, phyllites, schists do look like they could have come from a shale because they have micas in them and lots of aluminum. The alumina, that's one of the uh, differences in like the composition of a shale compared to the other protoliths is it's got a lot of clay minerals, a lot of aluminum in it, and that's what ends up growing all the micas. You don't see them in the slate, but in the phyllite, that's when they start to form. They're tiny little micas. And then a schist, they're large enough you can see with your naked eye.
Right. Yeah. Okay. I don't think I have any more questions.
Okay,
Mm, yeah, I think I'm pretty much good.
awesome. Well, good luck finishing the
So,
rest of it.
yeah, yeah, no problem.
I
This
think you're
is
on a good
due.
roll.
I'm sorry.
Sunday, I think I made it Sunday night, midnight.
Okay.
Um, and keep in mind, like for the metamorphic minerals, you're just identifying them. You're not trying to fill in any of the columns because it wasn't designed that way. I just had them, I just added them to the end of the table.
Oh, okay.
All right.
Yeah, no problem. Yeah. Thank you so much.
You're welcome. I hope that helps.
It will. Thank you.
Okay. You're welcome.
Have a good day.